Now, the second term and the third term, this is the second and the third, we can combine them together, right? The second and third, we can combine them together because we have x to the same power, which is the power n plus r minus 1, and the limits of the summation starting from n equal to 1, which is the same already. So these two terms, we can combine them together. And we would get minus an minus 1 times n to the power n plus r minus 1 equal to 0. Now we are going to do the comparing of the coefficients. So the first term, x to the power r minus 1, the right hand side is equal to 0, so you would say that a0r times r minus 1 plus 6 a0r is equal to 0. And if you take a look at it carefully, you will note that this is the initial equation, right? Isn't it? Divided by 2a0. Isn't it our initial equation? So that's why I told you that if you don't remember the initial equation, you don't need to remember it. Like after you plug y into our differential equation, you will end up with it. You will get it. See, and that from that you will get r, right? Equal to 0 and minus 1 over 2, which is because it is exactly the same as the one that we already find the value. And for we do the comparing the coefficients again, so we would get equal to 0 where n is greater, equal or greater than 1. This is the what you call recurrent relation. And then if you see that we have an here and an there, it's the same. You can combine these two terms together, so we would get 4 n plus r minus 1 plus 6 n plus r, the whole thing times with an equal to an minus 1, or an is equal to an minus 1 divided by 4 times n plus r minus 1 plus 6 times n plus r. We can use this when n is greater or equal to 1. Now, we have two values of r, right? You plug the first value of r is equal to 0, r1 is equal to 0. So we would get an is equal to an minus 1 divided by, you put r equal to 0 there, you would get 4n times n minus 1 plus 6n. Right, because you plug r is equal to 0 there. That is our first answer, because we are getting the recurrent relation of an. We find it from R1. N greater than 1. Now, if we put n equal to 1 there, we get a1 is equal to a0 divided by 2 times 3. Put n equal to 2 there, you would get a2 equal to a1 divided by 4 times 5. So this one is equal to 3 factorial. This one is equal to a0. 5 times 4 times 3 factorial, which is equal to 5 factorial. N is equal to 3, we would get a3 is equal to a2 divided by 6 plus times 7, right? It is equal to a0 divided by a0 divided by 7 factorial. And so on. When n is equal to n, you would get an is equal to an minus 1 divided by 2n times 2n plus 1, which is equal to a0 divided by 2n plus 1 factorial, right? Because you see, if n is equal to 2, you get 5 factorial, which is the second term there. If n is equal to 3, we got 2n plus 1 factorial, which is n equal to 3, 7 factorial. Now if we have an, it would be equal to a0 divided by 2n plus 1 factorial. Now we have y1, right? Because now we are using r1. So we get y1 is equal to summation an x to the power n plus r1. But our r1 is equal to 0. So we would get summation n equal to 0 equal to infinity an x to the power n, which is equal to a0 plus a1x plus a2 x squared plus a3 x to the power 3, and so on. And our a0 is equal to a0, a1 is equal to a0 divided by 3 factorial x plus a2 is equal to a0 divided by 5 factorial x squared, and a3 is equal to a0 divided by 7 factorial x to the power 3. Plus until an divided by 2n plus 1 factorial x to the power n plus. Now we take a0 and out. So we will get 1 plus 1 over 3 factorial and plus 1 over 5 factorial x squared plus 1 over 7 factorial x to the power 3 plus. Now because it is in the form of sine hyperbolic function, it pretty much looks like that. But we want to arrange, I mean, if you want to be done with this, that's fine. You don't need to rearrange it. Oh, a0. Okay? I mean, if you don't want to arrange it into the term of the function that we know, that's fine. I mean, if you can do just this, that's okay. Okay? But I'm going to do further in such a way that we are going to rearrange in the term of the function that we know. So is that I just times and divided by the square root x. If you look at here, you would see there you have 3 factorial there and have 3 up there. This one I have 5 factorial and have 5 up there too. And this one they have 7 factorial and have 7 there too. That is because we intend to do that. That this function is equal to which is the sine hyperbolic of square root x. That is our y1. This is kind of rearranged in such a way that we get a function. Like I said, if you're done with this, that's fine. You don't need to go further until you get the sine hyperbolic. Because in that case, you got to remember the whole form of its function. So sometimes it's a bit difficult. Okay. Now we are going to find the second solution by replacing r2 is equal to minus 1 over 2 into this equation. For this one, if I said an, if I say an will be the same as the first an that we do it before. So I put it as the an star in order to make it different. Okay, in order to make it different from our first r that we've already plugged in. Okay, I just put it as an a star. And then I just put the value of r equal to minus 1 over 2 into this Lagrange relation. Yes. In that case, I would get an minus 1 star equal to divided by we get 2n minus 1 times 2n minus 3 plus 3 times 2n minus 1. Then I just take 2n minus 1 out. Then inside we will get 2n minus 3 plus 3. Then we would get an minus 1 divided by minus 3 plus 3 all gone. So we get only 2n times 2n minus 1, where n is greater or equal than 1. This is our second relationship. And then we plug n equal to 1 in there again. We will get a1 star is equal to a0 star divided by 2 times 1, which is 2 factorial. N equal to 2, a2 star equal to a1 star divided by 4 times 3. But we know that a1 star is equal to a0 star divided by 2 factorial. So we would get 4 times 3 times 2 factorial, which is equal to 4 factorial. Which? This one? Up there? Further? Oh, hold on. R is minus 1 over 2. Yes, it's minus 2. Which one? This line? The first. Here? This one? Which one is the first one? Okay. It's 2. 2 minus 1. Because here, I just take this one up there. I got 2n minus 1 divided by here. We have 4n minus 1 over 2. We have 4 times n minus 1 over 2 times n minus 3 over 2. Right? Because 1 over 2 minus 1 is equal to minus 3 over 2. And then I just do this way. And then 2, 2, 2, 4. Understand? Okay. I just do the combine the terms in order to make it like a n minus 1 over 2, because I know that I have 4 here.